So we
Yes.
can begin with our first speaker.
Yes, Alexandre Meran, also from Novartis, and he's gonna show us a Jupyter Notebook tutorial. Hi, Alexandre.
Hi, thank you very much. So yes, I'm Alexandre Meran from Novartis, and yes, today I'll be introducing you to the Python and Jupyter Notebook tutorials. So the first part, I will show you how to use a beginner notebook. And afterwards, I will give you a brief presentation of the results of the intermediate notebook. So I'll start sharing my screen and start my presentation. So welcome to this training on the Iberia-Biscay-Irish region. So in this first notebook, I will show you all the ways to retrieve data and all the basic manipulation with Python on the Copernicus Marine Service products. So we've chosen here to look at sea surface temperature data. So we'll use a number of products. So one product will be based on model calculation. Another product will be based on satellite observation, and the final product will be based on in situ observation. So here are the three names of the product. So the Atlantic Iberian-Biscay-Irish Ocean Physics Analysis and Forecasts, European Northwest Shelf Iberia-Biscay-Irish Seas High Horizon L4 Sea Surface Temperature Analysis, and in situ near Earth observations. Okay. So maybe I should start by showing you how to download the learning material. So from the Padlet, you should have access to this Jupyter Hub environment, and the notebook will be here in the shared notebook folder. But you will have to copy this folder in your own user space. Otherwise, you won't be able to to do any modifications and to do your own manipulations on the notebooks. So I suggest writing a command similar to this one. So using the command copy, and this little command will enable you to copy the whole directory from share notebooks to your own. Here it's a directory that I've made myself. So I think someone will be able to copy this command in the chat to enable you to do this. So back to the material. So if you want, so back to the products. If you want to know more about the products, you can always see the dedicated pages. Here's an example with the model products. You'll have a brief description of how the product is made, how it's calculated, and its main characteristics such as spatial resolution, temporal coverage, and the variables that are available in the product. And you have also access to the user manual, the quality information documents, which are very useful, and you have the indication on how to access the data. There are several ways that I will introduce you now. So the first thing you can do to retrieve the data, to download it, is to download it from the catalog. So it's basically just going from this page, going to the products and clicking the download icon. And here you can choose your area of interest, etc. But I will not spend too much time on this because you'll have a presentation on this interface right after me. Another way is to use the multi-client protocol. So before using this, you just have to install the multi-client module in your Jupyter Hub environment using this cell. So this will install on your environment the multi-client application, And then running this command, so using MatuClient, you will be able to retrieve the product that you have chosen. So to know what the MatuClient link of your product is, you have to go back to this page that I've shown you, go to data access, and here you'll have the different links to for the MatuClient protocol. So here's an example. You copy the link here, and you should paste it here. Oopla. And then specify the name of the products that you're using, their identification, and you'll find all of this in this page, all the metadata you need. And then with date min, date max, you can specify the temporal coverage that you want to download, etc., the variable that you need, the directory you want it to be downloaded in, the name of the products, and of course, your credentials, your Copernicus Marine Service credentials, so the same that you've used to connect on this session. So those two cells download, here it downloads the model data, here it downloads the satellite data. Okay, so next method. There is also an FTP server that enables you to download the netCDF files. So here, the process is very similar. You have to enter your credentials here, so username and password, connect to the FTP, and now you just have to to use the product identification that you want. So same here, you'll just have to use the links and identifiers that are provided in this page. And it will retrieve you the netCDF files, and you will be able to choose which one of them you want to download. Finally, you can use the OpenDAP method. So in order to use, sorry, I'm just, okay. So in order to use this protocol, you first have to run this Python file here, which is saved here in the beginner directory. And just like before, it will make you enter your credentials, username and password, to be able to use the OpenDAP protocol. So same thing here. On the data access page of the product, you have the OpenDAP link that you can copy and paste. And in a few sections, you will actually see the product be downloaded. So we'll come back later to the OpenDAP protocol. Okay, so in this section, we will do a first exploration of the products with Python. So here are the Python models that we are going to use. We're going to use NumPy, which is very convenient for manipulating data arrays. If you are already familiar with Python, you're probably already familiar with NumPy. The netCDF files will be opened with the xArray library, so which is very commonly used to open netCDF datasets. And with Matplotlib and Cartopy, we are going to draw the maps, the graphs, etc. So here we import all those libraries, and we will be good to go. Okay. So of course, for this training, all the data has already been downloaded in this folder. So with these cells, we are just going to load all the data sets that we're going to use in this training. Okay, it's done. And here, Here's the comeback of the OpenTab protocol. So here's another example of how to open data. So with OpenTab, you actually directly open the dataset from the link. So as you remember, this is a link that you copy from here. Just make sure it's the right variable that you are copying, but this is a method. And just with this link, you can already open the whole dataset with Xarray. Okay, so let's see what we have loaded as products. So here is the model data that we have loaded here from the downloaded data. So here is our Xarray dataset. So there are many things to see here. Here are the coordinates variable of the data. So we have time coordinates, latitude, longitude, and many levels of depth. Here you have a brief summary of those. We have 12 time dates, 24 depth levels, and 181 latitude points and 865 longitude points. If we look at time, we can see that it goes from January of 2022, the 16th, to December of 2022. So we have 1 year of data with monthly values, 12 values, 12 months, it makes sense. And here are the data variables that are available here. So here we have the seawater potential temperature. The units is shown here, it's in degrees Celsius. And here is the water salinity. Same thing here is expressed as particle salinity units. So in this unit, you could say, like, you could translate it to grams of salt per kilogram of water. So this is the data that we have downloaded either from the catalog or the FTP or the multi-client methods. And here is the data that we've downloaded with the OpenTab protocol. And we see that it is a little bigger. So we have we have more time values, we have more depth levels, etc. This is because, and we have more variables. This is because, as we have only provided the link to the product in the OpenTab with the OpenTab downloading, we actually have downloaded the whole product, whereas with the multi-client and the other application, we are able to filter only the variables that we wanted and only the time coverage that we wanted. So here we can see that it goes from 2020 to 2023. And here we have many variables that we are not necessarily going to use. So this is something to know when you use OpenTab. You may want to filter your dataset afterwards. Okay, so now we have seen that we have the potential temperature here. So to select a variable in a dataset, you just have to use brackets like this and write the name of the variable that you want to study as a character string. So we can see here that we have the same coordinates, only we are only observing the temperature variable. So here's another variation of this using the salinity variable. So if you add data after the line, you'll only save the values, the salinity values of the dataset. So it takes some time to load as an NumPy array. So we might have to wait a few seconds for this to execute. Okay, so it's finished downloading. We can see that we have only raw values here. Those are the salinity values. Which are displayed, which are not easy to read, of course, because it's a big table that is being displayed here. So to have a better idea of the shape of our data, you can use the point shape method to retrieve the shape of the data. So here we see it's of shape 12, 24, 1081, 865. And if we remember, this corresponds to the coordinate variables of the data. So here are the latitude and longitudes. The 24 refer to the 24 depth levels that we had here. And 12 here, we have 12 time values. And well, the first shape of here is also 12. So it makes perfect sense. Okay, let's do some more manipulations. In this section, I will show you how to subset the datasets in regards to the coordinates. So here we look at the temporal coverage of the data. So you can select the time coordinate just like you select the other variables. So here we can see all the dates in the data. And if you know a date that you want to select, you can use the cell method and write here the date that you want to select. Here, for example, the 16th of January. So here we can see that we have only one time value left. And so here, logically, we have well, 12 times as less values as before, with only one date in the time coordinates. So it makes sense. So let's say now that you know you want to select a date, but you're not sure whether this exact date is in the dataset. So here, for example, I want to select the 5th of July 2022. But here, for example, the 5th of July is not in the data. We have only in July the 16th. So you can use the nearest method in the cell function, and it will select you as the name indicates the nearest date in the data. So if we do this, so we've tried to select the 5th of July, and if I look at my time coordinate that I have retrieved, I only have the 16th of July, which was the closest date. Next, you can also select a time coordinate according to its position, its index. So just add brackets and the index number that you want to select. So here I want to select the 7th value, because of course the index starts at 0, not at 1. And here, as I said, I've selected the 7th value, and indeed I'm on the 7th month of the data, July. And finally, this method is probably a method that you will use many times, which is selecting a range of data. So just like before, you'll use a cell function, but here you'll use the slice method to provide two dates, and it will select all the dates between these two. For example, I'm selecting from May to September, beginning of May to end of September. And if I look at the time values that I have retrieved, I have 16th of May to the 16th of September. So now I'm going to show you how to plot a map of data. So as it is said here, we're going to plot the sea surface temperature on July 2022. So first thing you need to do is to select all the data you need. Here, so I'm selecting temperature, potential temperature. I'm selecting depth equal to 0 meters because I want to look at the surface temperature. And I said I wanted to see it in July 2022, so I'm selecting my date, 16th of July. And all those lines are for drawing the map. So setting up the window, setting here the extent in longitude and latitudes of the map, the projection method. Here is the part where you draw, where you plot the data in the map. You can see that here, your variable that you have created here with all the selections is back here. And here are for the titles, legends, and the colors of the map. And this last line here is for saving the figure, saving the map in your own folder. So maps also take some time to draw. Let's just wait a few seconds. Okay, so apparently this cell has decided not to work, so we'll have to move on to the next section. Okay, so in the next session, I will show you how to manipulate the dataset values. So here we'll move on from the model product to the satellite product. Perhaps we can take a look at the product to see what it looks like. Okay, so apparently nothing is working anymore. I don't really know what's going on now. It should be very fast. Oh, okay, so the map has finally finished drawing. So, back to the map. So as you can see, we have plotted the sea surface temperature in July 2022. You have your color map here in degrees Celsius. So now the map is drawn, we are reassured, we can move on to the manipulating section. So here is our data set, and we can see that in our sea surface temperature, we have a value that is called analyze SST. So analyze sea surface temperature. So this is a variable in the satellite observation product that we are going to look at. So here we go. Just as I've shown you before, this is just selecting the variable. Here it's easy because there is only one. And so here this temperature is in Kelvin, and we want to convert it to degrees Celsius. And if we do that, we can just subtract 273.16 to the variable, and it will apply the subtraction to all the values in the dataset. And of course, you can save this result in a new variable and even save it into the dataset to have well, a new variable in the dataset. I can maybe try to do it live, but hopefully I won't mess anything. But I won't mess up. And you should already be able to write a new variable with this method. Here, new variable with in degrees Celsius. Of course, there are ways to do it cleaner than I did, because here you can see that I don't have any metadata like in the SST variable. Here I can click on this. There are methods to properly create a new variable with the specification of the metadata, so specifying degrees Celsius as units, etc. But if you want to work fast, this is a quick way to save a new variable in your dataset. Okay, so now I'm going to show you how to plot time series of data. So we are still using our satellite products. that now you are starting to know it. So now we can see that I have my new variable saved in the dataset. So we'll still be looking at selected at the analyze SST variable. And we're going to plot the time series from July 2022, the first to the end of July 2022. And of course, to plot the time series, we're going to select our data spatially. And so we're going to extract this coordinate point and see what the time series looks like. So here are our values. Here they are converted to degrees Celsius. So here are the 31 values on the coordinate point that we have selected. And with this cell, we're going to just draw the graph of the time series. Okay, so apparently now graph drawing goes fast, so it's perfect for us. So here in this minimap is the point that we have selected, that we have extracted the data from. And here is the time series. You can see it goes from the 1st of July to almost the 1st of August, so the 31st of July. And we can see here, for example, in this particular area, apparently the temperature has increased over July 2022. And as an exercise that you can do later if you want, you can try to do the same thing at another location. So basically, it should just be about changing the coordinates here. So I'll let you do it, and you can also do it on another month. Okay, so now let's plot vertical profiles. So in this section, we are going to study this time an in situ product and plot vertical profiles because those products cover many depth levels. So here is a little pre-processing of the data. And so here we can see that for one date, we have indeed almost 100 depth levels. So this is what will enable us to draw our vertical profile of sea temperature in degrees Celsius this time. Okay, so in this cell, we have drawn the three graphs. We actually have taken three different in situ measurements. So here are the vertical profiles, and each curve is the vertical profile at one specific date. So we have the 18th of July 2022, the 18th of June, sorry, 11th of July, and 24th of July 2022. And so as an exercise, you can always copy the previous cell and plot other indexes. Okay, in the next session, we will plot vertical slices. So we will combine depth level to data extraction at specific areas. So here we're going back to the model product, and we actually are going to select a slice on the map. So here it will go from this latitude to this latitude with a constant longitude. So we're going to plot a vertical slice here. And let's see what we have. So we're plotting this slice with all the depth levels available in this area. So here is the seawater temperature on the 16th of July. And we can see that it makes sense that near the coast, the depth is smaller than in the open ocean. And it also makes sense that the temperature is colder near the bottom than near the top, near the surface. Sorry. And so, as an exercise, you can change here the longitude and latitude values to plot another slice at another location. You can do it vertically or horizontally. It's as you like. Okay, as a final section in this presentation, we'll see how to create an animation of maps. So basically what we're going to do is in this loop, we're going to generate many graphs. And finally, we will animate them. So we will concatenate them together and make a GIF image. So this should take some time. So we're doing the same thing, a vertical slice. This is the same calculation that we have made before, only we're doing this on many dates here because we are looping it over the time variable. As we can see here, we are plotting the vertical slice for January, February, March, etc. until December. So the cell has finished executing, and hopefully we'll be able to see the animation. And here we go. Okay, so the animation doesn't loop, but I'm just going to re-execute the cell once more so we can see the animation again because it's really a really pretty animation. And we can really see the warming of the surface during the summer and the mixing of the water between summer and winter. So it was pretty relevant to plot this animation. And we are approaching the end of this beginner notebook presentation. So I hope you have enjoyed it. And of course, don't hesitate to come back to it by yourselves and do the little exercises that are specified here along the presentation. So